Easy BTech. I'm Dr. Gayatri. I'm going to explain you all on the topic time-independent Schrodinger wave equation. Based upon de Broglie's idea of matter waves, Schrodinger has developed a mathematical theory of wave equation for a particle that is moving. This equation of time independent will be describing how the particle will be moving in a given potential region. Okay, so according to de Broglie's wavelength, we know that when a particle of mass m is accelerated by means of a voltage, then the particle will acquire a velocity v, and wavelength is given as h by mv. H the Planck's constant, m the mass of the particle, and v representing the velocity of particle. This can be written as h by p. So from this expression I can write p equal to h by lambda. The kinetic energy of a particle which is moving is generally represented by half mv square. In this expression, multiply and divide the equation by m, which gives you m square v square by 2m, which we have already learned while doing with your de Broglie's hypothesis, is given as p square by 2m. But what is p? It is given as h by lambda. We have already found that. So you will now use even that substitution of h square by 2m lambda square. Next, psi of x is a wave function. This wave function will be explaining us about the motion of a wave. It is generally represented as a sine kx, or it is also said as 2 pi x by lambda. When I say kx, k stands for 2 pi by lambda. Now go for first differentiation of this particular expression. So when I differentiate with first derivative, dou psi by dou x will become a into 2 pi by lambda into cos 2 pi x by lambda. Okay, go for second differentiation. Then how does it reflect? Dou square psi by dou x square minus a 2 pi by lambda into sine 2 pi x by lambda. Here when I say by lambda, this by lambda is only for 2 pi by x, but not for complete term. So I'm once again writing this. It is 2 pi x by lambda. This by lambda is only for 2 pi x. It is not sine also. It is only 2 pi x by lambda. Now here minus a into sine 2 pi x by lambda is psi of x. So it becomes 2 pi by lambda, the negative sign into psi of x. This is what we are having for dou square psi by dou x square. So remember here, when I am doing here, this is with your power 2. Because here first derivation is cos. When I go for second derivation, sine. Once again I will have 2 pi by lambda, which is 2 pi by lambda whole square. So it becomes 2 pi by lambda whole square. This could be still written as 2 pi by lambda whole square, means I can still make it as minus 4 pi square by lambda square into psi of x. So simplify this expression for 1 by lambda square. When I write it in terms of 1 by lambda square, minus 4 pi square pi psi will be onto the other side. So it becomes minus 1 by 4 pi square psi into dou square psi by dou x square. This minus 4 pi square by lambda square is taken onto LHS. So we are getting here 1 by lambda square is equal to minus 1 by 4 pi square psi into dou square psi by dou x square. Now this 1 by lambda square which you are having, we will substitute in the expression of kinetic energy, your equation 1. So let's have that substitution to be done. Then my kinetic energy becomes h square by 2m. Instead of 1 by lambda square, I am going to write it as minus 1 by 4 pi square psi into dou square psi by dou x square. Okay, this represents you the kinetic energy. Now I want here the total energy of the system to be determined. So when do I have the total energy of the system? When I have both kinetic energy as well as potential energy. When did I get my kinetic energy? Only when I have potential to be applied, voltage to be given, the particle was set into acceleration. The particle was made to move and had a velocity, and I could give my kinetic energy as half mv square. So I have given some voltage. This is going to act for me as my potential energy. So the total energy of the system is the sum of kinetic energy plus potential energy, Ek plus V. So let's write what we have for our Ek. So our Ek is written as h square by 2m lambda square, but which we have expressed in terms of 1 by lambda square as so much. And we are going to write the same expression of Ek here. So while writing, make a simple change here. This is h square by 4 pi square. You have h cross to be given as h by 2 pi. But I am saying here h square by 4 pi square. So what will happen? H cross square becomes h square by 4 pi square. So I'll write here in place of Ek. Yeah, I'll make it as minus 1 by 2m into h cross square divided by sine. So what is this h square by 4 pi square written as h cross square, and minus 1 by 2m as it is. Dou square psi by dou x square plus v. Take this v onto the other side. Then what will be your equation? E minus v will be equal to minus h cross square by 2m psi dou square psi by dou x square. So I'll do with a small change here. Generally the students make a mistake because of which you will be losing the mark. Go with a step by step. Take your 2m psi h cross square onto the other side. Then it becomes 2m by h cross square e minus v psi of x, or psi will be equal to minus dou square psi by dou x square. Now since we are having this to be with a negative sign here, take this on to the other side. Then it becomes minus, no, here it becomes plus. So I have dou square psi by dou x square plus 2m by h cross square into e minus v psi of x equal to 0. This is called as time independent Schrodinger wave equation. Very important essay topic from this unit. This should not be left without preparation. It is highly important. So let's have a simple glance over it so that you can have a confidence while presenting. Actually, this equation, time independent Schrodinger wave equation, describes about the movement of an electron within the given potential region. So we know that according to de Broglie, the wavelength is given by h by mv, where m represents mass of the particle, v represents velocity of the particle, which is written as h by p. From this expression, I can write p is equal to h by lambda. Now, we are saying wavelength. That means the particle is moving here with velocity. So when the particle is moving, certainly it is having some kinetic energy. So I wrote this kinetic energy as half mv square, and I expressed it in terms of momentum as p square by 2m. But I got p is equal to h by lambda. So that has been substituted here to get h square by 2m into lambda square. But this is another case step that a student needs to remember. Psi of x is equal to a sine 2 pi x by lambda. Here when I say lambda, this lambda refers for only your theta portion, not with your sine. So dou psi by dou x is equal to a 2 pi by lambda cos 2 pi x by lambda. Second differentiation becomes minus a 2 pi by lambda becomes twice whole square into sine 2 by x by lambda. So from this equation, minus 2 pi by lambda whole square into psi of x, because a sine 2 pi x by lambda is the wave function. Already learned over here. So we are writing it as psi of x. Now from this expression, we are going to get the value of 1 by lambda square and substitute in your equation 1. So once we do with that substitution, you are going to have your 1 by lambda square equal to minus 1 by 4 pi square psi dou square psi by dou x square, giving your kinetic energy as h square by 2m into minus 1 by 4 pi square psi into dou square psi by dou x square. We know that h cross is given as h by 2 pi. H cross is given as h by 2 pi. So here you are having h square by 4 pi square. We can mention it as h cross square. So use the substitution of h cross square and this will be your answer. I have taken here the voltage because we have applied certain potential. Until we apply the potential, the particle will be in the state of rest only. Only when we give some potential or some other conditions there for it, there will be a movement in the change of the particle. So here for that we have taken with your potential energy. So it is given as Ek plus V, which could be written as, here we are having a minus 1 by 2m into h cross square into dou square psi by dou x square plus V. Now in this expression, this is the step once again generally made mistake by students. Take your plus V onto the other side, then focus on 2m by h cross square only onto the other side. Then you will be having your final expression as dou square psi by dou x square plus 2m by h cross square into a minus v psi of x equal to 0. This is my class for today. Hope you will be preparing with this time-independent Schrodinger wave equation, which is an important essay topic for your exams. All the best. Like, subscribe and share. Easy bit for you. Thank you.